All right, so we've got a couple homework problems that are due on Wednesday. They're 202 and 211. And 211 relates directly to problem 201. You know, you use your answer from 201 to complete 211. I did put the correct answer from 201 in problem 211 though, okay? So it's right there in the problem statement. Now, there is a little bit of an issue though in that I've made a newer version of this problem, 211, and that's not working at all, is it? Okay, there we go. Okay, so if you look on the cover of the packet that you have, I put this newer version in the fall of 2019, but there were actually two different versions of the 2019 packet. So this version of the problem occurs in the fall 2019B packet and also in the winter 2020 packet, okay? Now, if you have an older one, if you have the one that just says fall 2019 without the B, or if by any chance you have something older than that, you've got an older version of the problem, okay? And I have the new version here in my hand if anybody needs it, the newer version. I'm happy to give it to you. You know, it's just a little easier. This has the problem in 201 right in it, okay? There'll be some other problems that are like this too, and I've made copies of them. Oh, okay. Anybody else? Everybody good? Anybody else need? Okay. So now if you're online and you have this issue, I've got copies of the newer problems uploaded online that you can download. And I make reference to those when I list the problems out. Now this is also the case with problem 201, but if you did the older version of problem 201, I'll just grade it. It's not any big deal, okay? But the one I was doing in class to kind of review it for you was actually the newer problem, okay? That's what I was doing in class, okay? So it just has to do with which date of packet you've got. If you have the older versions, it's generally fine. I'll just give you the new problems when they come up. There's just another 3 of them or 4 of them, that's all, okay? No big deal. All right, so this stuff focuses on 3D moments. You know, we did that one already, 201. There was also 202, and then there's 211 are the different problems. So are there any, let's start and see if there's any questions on 202. You got anything up with that, with 202? It's the same process. I was wanting you to do it twice. I was wanting you to use 2 position vectors. So the general way you take a moment about A is it's equal to R crossed with F. Okay, and these are vector formulas. And the way I think about this is that, you know, the force vector is just the force you're applying. The R is like a wrench. So I just think of putting the head of the wrench on the thing I want to take the moment about, which would be the bolt. And then the wrench extends out to the point where the force is applied. So one wrench you could use would go from A to B. Now the other one you could use would go up to C. So it really doesn't matter. You know, the numbers you input will be different depending on which position vector you use, but the final answer will come out the same regardless of which one you use. So I was wanting you to do that one a couple of times with each of those 2 moment arms. So are we okay with that? Any questions? I mean, and so we're good? All right. Now, the other thing to remember about this, especially this 3D stuff, is, you know, I purposely give you the examples in class that just walk through it step by step. So if you have any questions on the homework, you just get that stuff out and just look at it. You know, it's their processes. You find the vector, you know, if you're doing this problem, you're going to find the vector from B to C. You're going to take the square root of some of the squares and get the length of it. You're going to divide that out and get a unit vector, and then you're going to factor that up by the magnitude of the force. That will get you the force vector. Then you're going to find the vector from either A to B, and then do that, and then do a cross. And then you do the vector from A to C and do a cross. That's how you do it, okay? And there's a very distinct process that we go through in class. So the notes you take in class are a template for how to do these problems. I mean, that's the intent of that. Okay. You okay with that? Okay. All right. So we did. I went through 201 quite thoroughly too, and I've posted those notes as well. So that was the one you turned in today, but it's just another moment problem similar to these. Okay. All right. But the other bit on 211 might require a little bit of explanation. So we get on 202 questions? Yeah. Good. All right. All right, so 211 works off at 201. And so, again, what we did there was we got the coordinates on the points. Started with that. Then we found FCD. We wanted from C to D, so we took RD minus RC. We got FCD. We took the square root of sum of the squares and got the length, which would be in meters, 2.61. We divided that out and got a unit vector. We then factored that up by the magnitude of the force, which is 1800. We got a force vector. Then we found the vector that went from A to C by taking RC minus RA. We did the cross product, R crossed with F. We have that formula on the formula sheet that allows you to do that, and we came up with the moment vector, something on the order of minus 2933I minus 3091J plus 1573K. So that's the moment of that force about A. That's 201, and that's the one you're turning in today. Okay. Now 211 extends on that. So you start with that vector that I just outlined, the moment vector. Okay, you find that first. And I put that vector into the problem statement for 211, so it's there if you need it. Okay, it's right there in the problem statement for 211. Okay, the newer one anyway. Okay, and now the question is, if you let's find the amount of moment that would occur about this axis that goes from A to B. Okay, and express your answer as a vector and a scalar. So you start with that moment vector about A, and then what you need to do is to find how much of that creates a moment about that axis from A to B. Okay, so that's the problem here. Okay, so the process then will be to take that moment vector, and let's have a look at that moment vector, minus x minus y plus c. So minus x minus y plus c. I'm just going to try and sketch it. So minus x, a little bit, minus y plus c, about half as much. So there we go. So there's the moment vector. That's m sub a of that force. If we want to figure out how much of that force causes a moment about the axis, what we do is we find a unit vector for the axis and we dot them. And when we do that, what we're doing is we're finding the projection of that moment vector onto the axis. So that's a right angle there. Okay? That's what we're finding. So what we're going to do here is fairly straightforward. We're going to find a unit vector that goes from A to B. So that's what I'm doing there, is I'm taking RB and I'm subtracting off RA. Remember, this, if you want to go from A to B, what you do is you take B minus A. You got to remember to switch the letters around. So to go from A to B, it's 2.7, negative 0.4, and negative 1.8. That's how you go from A to B. So that's the vector that does this. Okay. But I want a unit vector, so I'm going to take the square root of sum of the squares and get 3.27 meters and divide through by that, and I will get a unit vector. So that points the direction from A to B. So that's a shorter vector, generally speaking, and that's going to go towards A to B, and that has a length of 1. Okay? So I find the vector from A to B. I find the magnitude of the vector by taking the square root of sum of the squares, and then I divide through by that, and I get the unit vector. So we good with that? We got any questions on that? Okay. All right. Now, to find the projection of the moment vector onto that unit vector, you use a dot product. That's how you find projections. You do a dot product. Okay? So that would be the next bit here. And all you got to do is do a dot. So you're going to take the moment vector, minus 2933, negative 3091, and 1573, and you're going to multiply that by the like unit vector components. So negative 2933 times 0.826, negative 3091 times negative 0.122, and 1573 times negative 0.551. You multiply those together, and you add up the products. So you get three terms, and you just add them up. They're just magnitudes that you add up. And that gets you negative 2910, which means that that projection actually goes not from A to B, but from B to A. So the moment B to A is 2910. So what that tells me is that moment is coming around like that, because if I take my right fingers and turn them that way, my thumb will point from B to A. Okay. So if you take that moment about A and apply it here, what's going to happen is you're going to spin that plate around that axis AB with a magnitude of 2,910 Newton meters. That's what we just found out. So that's the basics of finding the moment about an axis. So it's one more step after finding the moment vector. You then project the moment vector onto a unit vector for a given line that represents the axis. Okay. Now, if I want a vector form of that, because what I just found is a magnitude, 2,910 Newton meters, so if I want a moment vector for that, I just take the 2,910 Newton meters. I keep the sign because what I did there, this is for AB, it's a negative for AB. And then I just multiply that through the unit vector for AB. So what I'm doing there is I'm taking MAB times the unit vector that goes from A to B. And what I get then is a moment vector. So I can get both forms of the answer there. Questions on that? Doing all right with that?